Let's talk about how Robert Millikan and Harvey Fletcher discovered how much charge electrons have by using their oil drop experiment. Now, I think the oil drop experiment is like one of the coolest experiments in all of science. Now, before this happened, in 1897, J.J. Thomson discovered that atoms have electrons, and he discovered that electrons have negative charge. But he wasn't able to figure out how much negative charge electrons have, because charge is something that can come in different amounts. So scientists wanted to be able to put a number on it, figure out exactly how much negative charge each electron had. This was a tricky thing to do, though, because you can't just take an atom and pull out an electron and measure its charge. So what Millikan and Fletcher had to do is use a really clever technique. They used tiny drops of oil and balanced them floating in midair by using gravity and electricity. And believe it or not, using this technique, they were able to determine how much charge each electron had. Let's talk about how. Here's the equipment that Millikan used to do the experiment. This is like a big chamber, and I'm showing a cross-section of it here. Now this is the atomizer. It's just like a perfume mister, except instead of spraying perfume, it's spraying oil into tiny little droplets. And these droplets spray out into this area, and some of them float down here in between these plates and end up in this area. Now these drops are really, really tiny. So there's a microscope in one side of the chamber so that the people doing an experiment can look through the microscope and see individual drops. They try to focus on one drop at a time. And here is what they'd see. They would see one of these drops slowly floating down here to the ground. Now why is that? Well, it's because there is a gravity force that is acting on this little oil drop, pulling it downwards. But the gravity force isn't the only force pulling on this oil drop. There's also an electric force that is pulling it in the opposite direction. Here's where the electric force comes from. As these drops that spray out, as they make their way through the chamber, some of them lose some electrons. And as they lose electrons, as they lose negative charge, the drops become positively charged. So I can indicate that here with this positively charged drop here. Now, these plates are special because they have an electric charge on them. They're hooked up to power here, and the top one has a negative charge, and the bottom plate has a positive charge. So here it is. Here is a positive charge on the bottom, and here is a negatively charged plate on the top. Now, the oil drop is positively charged. Think about how electric charges interact with each other. Well, like charges, the same type of charges repel. They push away from each other. So the positively charged oil drop is going to be pushed away from the positively charged metal plate that's down here. And then on the other hand, opposite charges attract. So the positively charged drop is going to be attracted to the negatively charged plate that's up here. All of this adds up to an electric force that is going to be pushing in this direction. And it's going to be pushing in the opposite direction of gravity. So it's like these two forces are going to be battling it out. One pushing down, one pushing up. Who wins? Well, it depends on how strong the electric force is. And the electric force depends on the charge that's in these plates. Let me show you what I mean. These plates have this voltage dial that's hooked up to them, so that it's possible for the people doing the experiments to change the amount of power that's going to these plates. So they can turn it up or they can turn it down. All right, so we've got this oil drop here. Let's say that we can crank the voltage way, way up. Here we go, crank it all the way up to 10. Now, when the voltage is really high, there's a lot of power in these plates, so they have a very strong charge. And because they have such a strong charge, the electric force that that's going to create on this drop is very big. High voltage, lots of power, big charge, big electric force. So the electric force you can see is really large here, and it's much bigger than the gravity force. So since they're trying to cancel each other out, the electric force is going to win because it's much bigger. And that means that it doesn't really matter that the gravity force is pulling down because the bigger force is moving up. So the oil drop is going to move upwards because the electric force is winning. So I can kind of sum this up here, where with a high voltage, the drop moves up because the electric force is bigger than the gravity force. But on the other hand, we could turn the voltage way down here. And what that's going to mean is that there's much less power in these plates, less charge, and so the electric force that's acting on the drop now at the lower voltage is not very big. It's just a small little electric force. And now, when it tries to cancel out the gravity force, it's much too small. The gravity force is going to win. It's the bigger force. So that means that in this case, the gravity is going to pull the oil drop down. And that's what this situation is. Low voltage, drop moves down because gravity wins. Now, what if we could adjust the voltage so that it is just right? And by just right, I mean that we find a voltage number where the upwards electric force on the droplet gives exactly the same amount of pull as the downward gravity force. Okay? So if the voltage is a little too high, the electric force is going to be bigger than the gravity force, so the drop moves up. If the voltage is a little too low, the electric force is going to be smaller, so then the gravity force wins and the drop moves down. But if we get the voltage just right, the drop isn't going to move up, it's not going to move down, it's just going to float in midair. And that's because the electric force and the gravity force are both pulling, but they're pulling the exact same amount. It's like two teams trying to play tug of war, but both teams are equally strong, so they can't move the rope in either direction. So when the electric force exactly equals the gravity force, the oil drop is just going to stay still. When this happens, electric force equals the gravity force. This is a very important situation, and it's what the people doing the experiment try to do. They adjust the voltage, looking at a single drop, until they can get it just right so that the drop stays still. Now, for each drop, they do this with many different drops. For each drop, they find a way to determine the mass of it, how much it weighs. So for this one, let's just say you write the mass down, and then they write down the voltage at which it balances, staying still. And they do this for many different drops. They do it for many different drops of different sizes. And for each drop, they measure the mass of it, and then they measure what the voltage is when that drop is balanced. They take these numbers, and then they're able to plug them into some equations to figure out what the amount of electric charge is on the drops. That's what we'll do next. I'm not going to go into all the details of how they do the numbers and everything, but I want to give you a conceptual understanding of how they think through the problem. Now here's how they figure out what the charge of an electron is. Okay? They have all of this different data. For each drop, they have its mass, and they have the voltage that's required to balance it steady. Okay, now, we can say this, that when the drop is balanced, the force of gravity equals the force of electricity. Now, the force of gravity depends on the mass of the drop, as well as a few other things that we don't want to have to worry about here. The force of electricity depends on the charge of the drop and the voltage on the plates. And remember that when the drop is balanced, these two things equal each other. So in other words, this is an equation that you can solve for one of the variables. Now, they know for each drop, they know its mass. So this is a variable that they know. For each drop, they know the voltage that's required to balance it. So they know this. And because this is an equation, they can solve for the charge of each drop because they know this, and they know this, and they know that these two things equal each other. Now, using this equation, they're able to determine the charge on each drop. Here is a list of some of the charges that they might be able to come up with. I've simplified this somewhat from the actual experiment. These numbers are measured in zeptocoulombs, which is a tiny, tiny amount of charge. And look that all of these numbers are positively charged. That's because, as we said earlier, the oil drops are positively charged because they've lost some electrons on their way through the chamber. Okay, so they're positively charged because they've lost electrons. When they start looking at these numbers, they notice something interesting. They notice that there is a pattern in the numbers. And here's what it is. All of these numbers are multiples of 160. Okay? So look, this is 1 times 160. This is 2 times 160, 3, 4, 5, and so forth. And so they say, look, these drops of oil are losing charge in multiples of 160. So they think, aha, each electron must have 160 zeptocoulombs of charge. Because if you lose 1, you have 160 plus charge. If you lose 2 of them, you have a plus charge of 320. So the drop that has this charge lost 1 electron. The drop that has this charge lost 2. This one lost 3. This one lost 4. This one lost 5. That's where the positive charge is coming from, because the drops are losing different amounts of electrons. But they see that the charge difference is always a multiple of 160, the smallest amount of charge that you can lose when you lose 1 electron. So based on this information, they're able to determine that the charge of 1 electron is negative, remember, because electrons are negative, is negative 160 zeptocoulombs. You can also write this as negative 1.6 times 10 to the negative 19th coulombs. Coulombs are just a unit that you use to measure charge. Or it can be written as negative 0.0000160 coulombs, a very, very tiny amount. That is how, with the oil drop experiment, scientists were able to first measure the electric charge on an electron by taking tiny little drops of oil and balancing the downward gravity force with an upward electric force.